Dun, dun, dun! Application problem. Oh, you guys knew this was coming. You know how I operate. We can't get out of doing these lovely, lovely word problems that you have grown to adore. Ah, who am I kidding? Most people don't like word problems, but you know what? They're a necessary evil, and they're going to be on iStep. And the only way to get good at these things is to face them head on and practice them. All right, what's it say here? A triangular logo on a building has its base equal to X meters. The height of the triangular logo is 5 more than twice the base. If the area of the triangular logo is 3.5 square meters, calculate these three things: value of X, base, height. Okay, let's draw a picture first. Okay, let's draw some triangle, and it says the base is what? What's it say the base is? The base is X meters. Okay, I'm going to treat this as my base. And the height is what? The height is, what's that say? The height is 5 more than twice its base. Okay, the base is X. 5 more than twice the base. 5 more than twice the base means I take the base, I multiply it by 2, and then I add 5. So our base is 2x plus 5. And we know the area of that whole thing is 3.5 square meters. Now we have a formula to find the area of a triangle. It's BH divided by 2. Base times height divided by 2. I swear I did not say a bad word. I know it sounds like I did, but I didn't. BH, base times height divided by 2. Okay. Now, hello. Sorry. Yeah, thanks. Okay. The area, we're told, is 3.5 square meters. And what we want to do now is fill in the base and the height. So remember, this x was our base. This 2x plus 5 was our height. And we want to substitute those two things in to our b and our h to be able to solve for what x is. So let me do this carefully. Base is x. The height is 2x plus 5. All divided by 2. All right, we need to get 0 on one side of the equal sign, but I'm going to do something a little bit different first. I actually want to get rid of this fraction. I want to unlock my upstairs first, and to do that, I could do two things. I could multiply both sides by 2, or I could put this side over 1 and cross multiply. And in the end, you're still going to end up with the same thing. We're going to end up with 7 equals x times the quantity 2x plus 5. Okay, now let's distribute our x through, and then we can worry about getting 0 on one side of the equal sign. So let's see, x times 2x, that's 2x squared. X times positive 5 is plus 5x. And now we need to get 0 on one side of our equal sign. How do we do that? We're going to subtract 7 from both sides, right? Of course, you knew that. Okay, it's not a naked quadratic. We're going to have to multiply front end times back end. 2x times our negative 7. What's 2 times negative 7? 2 times negative 7 is negative 14. And then our two numbers that we need to find also need to add to what's in the middle, which is a positive 5. Okay, what two numbers multiply to negative 14, but at the same time would add to a positive 5? What do you think? I'm thinking it would be 7 and negative 2. Okay, let's check that out. What the heck? Come on. 7 times negative 2 is negative 14. 7 plus negative 2 is positive 5. We are in business. We've got our lucky lotto numbers. Now what we need to do is go to our handy dandy table here, fill stuff in, and solve, eventually be able to solve for x. To do that, we need to fill in our table, factor out GCFs. Once we have GCFs factored out, we can then solve for x. First box, first piece. Last box, last piece. Along the diagonal, we put our lucky lotto numbers, attaching the variable to it. And now we want to start factoring stuff out. GCF of 2x squared and 7x is ordinary plain old x. GCF of negative 2 and negative 7 is negative 1. We can't take any x's out because this box has an x, this last box does not. Too bad, so sad. Move on. First column, GCF of 2x squared and 2x is 2x. GCF of 7x and negative 7 is positive 7. Again, remembering to factor out the sign closest to where we are factoring. That 7's positive, and so we're going to take out a plus, and it just also happens to be 7 that we're factoring out as well. Now that we have our factors, we can now set these side by side equal to 0. And we're going to set each piece equal to 0 and set and find out what our x values will be. This first equation, to solve it, subtract 7 from both sides, right? Divide both sides by 2. And so one solution is negative 7/2. This equation, to get x by itself, we add 1 to both sides. And so the other possible solution is 1. Now, because this is an application problem, it is possible that only one of these solutions makes sense. What did x mean? X was referring to the base of the triangle. That has to be something that's positive because it's a length. The value of negative 7/2 is trash. It's garbage. Get rid of it. Like it's yesterday's news. Forget about it. That can't be a value that makes sense for this problem because a negative length is nonsensical. It doesn't make sense. So what does this mean? Our base is 1. Oh, that answers part B. Okay, part B, base is 1. And why is the base 1? Because the base was x. What was x? That made sense. X was 1. To find the height, well, the height was 2x plus 5. Let's substitute 1 in for x and find out how much our height is. 2 times 1 is 2, plus 5 is 7. There you have it. A nice application problem solved using the factoring method to solve quadratic equations. It really is a sight to behold, is it not? I hope you've enjoyed it. I know I have. All right, gotta go. Have a good one. Oh, getting a phone call. Don't know who you are, leave a message. Okay, anyway, bye-bye.